Good evening and welcome, one and all. Uh, I am your co-host. My name is Severin Vaz, and I work at SG Innovation as an assistant manager. And we are going to have this webinar on hands-on React. And here are your speakers, Denzel and Sanat. Okay, so a little bit about SG Innovation. Next slide, please. Yes, so we are SG Innovation, and this is our motto: employee happiness, generate client success, and we live by this. So a little about SG Innovation. Uh, we and we are an 18-year-old company started by Shahid and Shaira, who is the CEO and CEO. And we are presently located in 5 countries. Basically, New York, our head office, where the company was started, India, Goa, 2 offices in Bangladesh, Select and Dhaka, and 1 office in Ukraine. So we are basically around 170 plus employees, and we are a culture-based company. Next slide, please. So these are our culture points, and we live by this culture point. So first one is be humble, then do great things together, work to make clients successful, take accountability, embrace challenge and grow yourself, and help each other. Yes, next please. These are some of our services, that is healthcare software solution, quality assurance in UAT, Drupal development, email and landing page design, Magento services, AWS cloud services, cross-platform and native app development. Yes, next please. Besides, software development and all of the above mentioned service, we also, truly believe in giving back to the community. Thus, we are involved in a lot of non-profit community outreach organizations, and also we do a bit of charity. So that's a brief about SG Innovation and few details about a company. So next, here is your first speaker, Denzel. Please take over. Yes, Denzel, please.
Uh, Hello, good evening, everyone. So today we'll be starting with our presentation today. So our topic today is React. So let's just dive into it. So what is React? React is basically a JavaScript library used to build fast and interactive user interfaces for both web and mobile applications. Now, one thing that makes React extremely powerful is the fact that it is open source. Any user can access its source code, modify it, or enhance it. So in a typical model view control architecture, React defines the view part of the application. It is responsible on how the app looks and feels. Now let's just see why to use React. React helps us to for creating not only just dynamic web applications, it also provides performance enhancements like virtual DOM, JSX, etc., which we'll be covering later in the slides. React also provides us the ability to do reusable components, which decreases the overall downtime of the development. React also has a small learning curve compared to its other competitors such as Vue and Angular. React can also be used for mobile application. React has launched and released an extension called React Native that is used for development of mobile application that is cross compatible. Before we dive into more into React, let's just familiarize ourselves with the concept called as single page application as well as multi-page applications. So in traditional websites, we have a template for each and every page on our website. So we have every time a user comes and requests for a page, we have to return a new page every time the request is to send us a request. But with the single page application, only one template is sent. Basically, a one HTML file is rendered at the first start, and the remaining concept on the page is dynamically handled with the help of JSX. That's JS. Now, the term single page application can be a bit misleading, as one may think that in a single page there must be only one page, but in reality, it's just one template, and the rest of the content is modified and dynamically shown using the help of JSX. Uh, Continuing with the same logic, let's just see what one of the main features of the React, that is virtual DOM. Understanding this will not only help us with understanding how the React performs, but also how it is faster compared to our normal HTML, CSS, and JS. I in virtual DOM we also have something virtual DOM is basically a feature of React that helps us to not only build but also update our DOM. It is in the complete life cycle of our component. So React keeps a lightweight representation of the DOM in memory, which we refer to as a virtual DOM. So when we change the state of a component or in a component, we get a new React element. React then compares this new element or its children with the previous state or the snapshot that has been taken during the first render, and then it figure out what has been changed or where the update has been made. And basically, depending on the changes, it will make the possible amends on the real DOM as well. This basically changes avoids helps the developers to no longer communicate with the DOM API with the browser like we used to do before when we used to work with a normal JS or with jQuery. Following up with this, there is something called a JSX. Now, JSX is very much familiar, is very much same to the normal HTML, CSS, but the only difference over here is that there is slight syntactical issues, differences compared to our normal HTML, CSS. If in React, we generally be using JSX, which stands for JavaScript XML. JS looks a lot familiar like HTML with slight syntactical differences that also gives us some additional features. Let's take a look at the image on our on the top left on how we can use the curly brackets for inserting variables or JS logic directly into our HTML. This is more notable differences as we will proceed further. The browser, but the difference over here is in traditional browsers can't read JSX directly, so we need something called as a transpiler or a compiler that acts as a middleware that compares this JSX, the high level language, into a normal machine learning language that can be understood by the browser. So this over here, the transpiler will convert the the JSX to normal HTML, CSS, and JavaScript code, which will be understood by the browser and will be rendered on the screens. JSX, the one of the core logic for the React is the components. What are components? The component is essentially a piece of the UI. So when you're building an app with React, we build a bunch of independent, isolated, and reusable components, and they compose them to build a complex UI. Every React have must at least have at least one React a component that is also known as a root component, which we normally refer to as the app. This component represents the internal application and contains other components. So every React app is essentially a tree of components. So if one there is one component, there can be a multiple based on it. So this is how the React tree looks like. Component tree will look like. The each and every component has its own lifecycle methods. How this works is understanding this lifecycle method will only not only help one as a developer, but also will give insightful knowledge on how to debug if there is any issue of followed while development. A React component has a life cycle that goes through, and there are three main phases for these life cycles. Every component has a mounting phase when when it is first added to this DOM, updating place when we are modifying or doing some amends, so the component needs to be updated, and unmounting phase for when the component will be removed from the DOM. Understanding these three lifecycle methods will be very beneficial for the developers. So one has to know on how to on getting a good grasp of this component lifecycle. So there are two types of components in React. There are class-based components as well as the functional components. Let us these are on the left hand side. The image depicts the three lifecycle methods of for the class-based components that are component did mount, component did update, and will mount. And on the right hand side, it is for the functional component, the use effect hook, which we'll be looking at. So the use effect hook covers with the minor amends in it. It will be covering all three of the lifecycle methods on its own. Let us look at what is class-based component and functional components. Now there are few changes or in class as well as functional components. One is most notable, that is the syntactical. Another one is in class-based components, we derive the components from the classes itself, whereas the functional components, we are just directly getting the writing the functions in the plain JavaScript format, in the functional format. In the class view component we also have to use we have to use the word of this, whereas in the functional components we don't require the this keyword. One of the main that is technical difference between class and the functional component is that whenever you declare a state in a class based component, it is mutable because it is declared in a normal JavaScript object, whereas in functional components we have to declare it saying a const square brackets and some variable names equal to useState. So over here, the difference is it is not mutable. Every time the state changes in the functional components, a new tree is generated that is completely different from the previous state. So this is one of the most technical difference between the class base as well as the functional component. Moving on to what is states and props in React. Now, the lot of people will be very much confused with what is state and props. Now, the most notable difference I would say is the state is something that is inside the component, whereas a prop is something that is passed on to a component, which can be passed in down the tree or the up the tree. A prop is a short form for the word called properties or acronym. The state can be passed as a prop down the component tree, but and every time the state will change, it will trigger the component to re-render. But a prop can also be a state as well as a normal variable as well. Like for example, if we have a title for a page, we can store it as a normal text in one static text in one component and pass it down to the lower component, and every time we hit on the page, the title won't be changing, so we won't require to re-render. So this is one of the main change differences between a state and a prop. Another one will be using the counter operator. Whenever we have a counter, the state changes. Whenever the state will change, the counter will change. So this will require the entire component to re-render. So whenever we change down the count to a lower component tree, so this can be changed as a prop. Handling events in React is very much simpler and similar to one that we used to do in normal HTML JS also. The only notable difference over here is in React we use the camel casing, whereas in the normal JS we used to use everything in the lowercase. Over here, we can directly add the events on the JSX itself, and we don't need to require or the code to do like element add dot event listener or document or get element and anything. We can directly just add these events on the JSX element there itself, and it will be triggered over on the mouse click or on submit or whatever event that is listed as. The only notable difference is to use the camel casing. How to add CSS in React? We can add CSS in React as well as like the normal way. The first way is the inline CSS, wherein if we are writing some inline CSS, we will have to make use of a double curly braces, as well as we'll have to define the classes as the objects. We can also add external CSS class like we shown in third one. So over here we can just create a separate CSS file like we used to do in normal HTML CSS, and just give it the path. And the third one is the using the word of class name, the keyword called class name. Normally we used to just use class, but in React we have to make use of the keyword called class name to define classes. uh, we'll be going on to the hooks, which is more important in React for the functional based component, and this part will be covered by my colleague Sanath.
Yeah, thank you, Dazil, for the giving us the introduction on initial part on React. So, as Denzil has already mentioned in his previous slide, that we had something called as class-based component and a functional-based component. So initially, when React was being developed, uh, people used to follow class-based component, but and functional based component were mainly as a presentation purpose. So we did not have any logic to handle the state or any action during any sort of event. But after React 16.8, there was an introduction of hooks in React. So the reason why they were more focusing on functional based component was they were simple to use, less code was needed. If you compare with the class based component, also you don't need to have any constructor. Also, if you are using a class based component, you must be familiar with something called as this keyword, and then binding the this keyword with the event, so that all the issues were being eliminated, and it was making the development process more simpler and easier. Basically a function basically sorry or functional component is anything which returns u and jsx. So that's a difference between a normal function and a functional component. Functional component will always return you basically a jsx element, whereas a normal function returns you some values and all. Also, hooks basically allowed or given some additional you can say powers to React component, wherein it was able to handle its state, also access certain life cycles, which Denzil had already spoken. And there were some life cycles which were there in the class-based components that were basically were no longer being used. Uh, so let's go on to first component which is there. First, we will just go through the definition, and then later on we will see some code and how that thing is being implemented and what are the use cases of it. So first is the state component, state hook. So a state hook, as it names suggests that it is used to manage a state of a particular functional component. Now, here our aim is that we are trying to keep a functional component as a pure as a pure function. What do you mean by that? That means the functional component is not handling the state part. That responsibility is being given to some other function. So thus there is no side effects for that functional component. So because of that, there was a concept of hooks. It's very difficult to maintain side effects because there will be some actions which will be fun form. That means you are trying to use a fetch request, or you are trying to make any DOM manipulation. So we are trying to use hooks to do all those things. So yeah, so we will see the this is the syntax. Second point of hooks that we should remember is hooks basically takes an initial value, then it compares, and if it finds a difference, and then it re-renders the component. So one thing we should remember is component is being mounted only once, unmounted only once, and component is re-rendered multiple times depending how many states are there. So every time a state is being changed, that means that component is being re-rendered. That is, that function is being recalled. Component is mount only once, so that the only the value which are there, it is being updated. Then let's move on to the second one, which is useRef. So useRef is similar to the use state hook. The only difference is when you make any change in the useRef hook, it doesn't triggers the re-render. So it can be used for any inner calculations which you need, wherein the data should be persistent between both the renders. So useRef can be used for that. It is not suggested to use useRef for basically getting the input from any element or so, because we are mostly trying to use or keep our forms more stateful. So useRef can be used only during the calculation. Let's say you want to find out how many renders are happening. You can use useRef for that. Then third hook is useEffect. So this hook basically gives an ability that you want to execute some logic in a particular life cycle. Let's say when a component is mounted, I want to execute some fetch logic, or whenever a variable is being updated, I want some logic. And also during the unmounting process, I want to run some logic. So So there are three life cycle which can be accessed, and in the use effect hook there is a dependency array. In the dependency array, if it is blank, that means only when a component is mounted, that time whatever logic is there inside use effect will get executed. If there is a variable mentioned, basically a state, that means when a component is mounted, that time it will execute, and second time when that state is being changed. And one more thing is that if you don't put dependency array, that means every time whenever a state is being changed, that time it will execute irrespective of which state you are changing. Then second is use context hook. So use context hooks you can consider is like um when you have like a bigger application, and you want to pass some data between the sibling nodes or sibling component. So what you basically do is you lift that state to the parent, you give it to the parent, and then you pass it down to the child. So so there will be some components wherein they will be accessing those props which are actually not needed. So in order to counter that, we are using use context hook. So use context hook basically gives you an ability wherein you wrap some components, and those components can access that state, whichever you are mentioning. Then use callback hook. Use callback hook is useful when you want to cache any function. So as I said earlier, like every time you update a state of whatever thing which is there inside that within that functional component is regenerated. So in case of function, what is happening is they are recreated. So that means a new reference value is created. Arrays, objects, and functions basically they operate on references, and they are non-primitive values. Then third thing is use memo hook, which basically memorizes the result which is given by a function, so that if there are a lot of expensive logic which is being written, and if that same thing is coming again and again, so it doesn't has to calculate that thing. It knows that already it is being calculated, and we can just directly show it. Then third is the use reducer hook. So use reducer hook is you can say makes use of use state and use context. Um, with that total, if you use state, use context, use reducer hook, basically gives you an ability of similar type of redux thing. So use reducer is hook is good when you have a lot of complex states, or you have multiple states in your component. So instead of creating multiple state, you can basically create a single object, and inside that you can mention whatever states are there. So I will show you an example of that. So first one is a use state. So this is how you define a use state. So here, uh, let me know if you're seeing my screen. I think it, I'll reshare my screen. Yeah. So first hook that we have studied was use state. So use state basically you have to import it here in the import section, and this is how you define the state, wherein this is an array. So basically you are doing an array destructuring. Here is the initial value which is being set. This is that variable name which will be holding that value, and this is a setter function. So setter function is responsible for updating that variable, and it should be used every single time whenever you want to update a system. You cannot directly update the count just by saying count equal to 0 or 1 or 2, because if you do that, then re-rendering won't happen, and re-rendering won't happen, and also the data won't persist. So we have to make use of a setter function. Any name can be given, but mostly this convention is being used whenever we say if it is count, then we say set count. So this type of convention is used. There is no like any strict rule that like we should use this format or so. Any name can be used. So once you declare a use state, so basically what I've created is simple counter app wherein there is one counter which is there. Yeah, it's a state and there is an increment handler. So here I am basically incrementing that count. So if you say count plus one, it will increment. So just a second. Mm, Screen. Mm, So here is that counter app, and I'm not sure whether you are able to see the code here. Uh, So basically, this is that counter app. So whenever I increment the counter, it's get updated. So this is a simple use state hook. Then uh, so this is the increment handler, and this is how you update the state. So once that is done, one more thing we should be careful is that if you have like this some logic similar increment function is there, and let's say, so if you have like this, and let's say you have put a one console log over here, and you are trying to console log the count value, the count value won't be shown immediately, because what happens is when you click on that button, this increment handler is being called, this is being executed, and then that execution is not entirely being completed. So JS won't work for wait for that. It will directly execute the console statement. So at that time, console value will be the one which is there in the current. And once it reaches the end of the function, it will return the control to the React, and then the React will update the counter, and then you will see a re-render which is happening, and then you will see the real output. So this is one thing we should remember, because most of the time we put console log here and try to see if it is getting updated or not. Second thing is, let's say you want to take any a better way of doing this thing is, you pass a callback function and you say that this is previous count, and then you can say previous count plus one. So if you do this way, this is actually a proper way of doing it, so that you get always a latest count. If you say like this count set count, and again you duplicate if like this, and if you see the output which is there, the count will be 2. So initial value is 1, and if you execute it, count will be here 1 plus 1, it will show 2, and here also 1 plus 1, it will be showing 2. That's because of the closure which is being formed for this. So both these are running, this will have its own closure and this will have its own closure. So it won't update immediately, and you will see like it is not getting updated twice. So for that you can use something like this, wherein you pass a callback function, you take the previous value and update it. So if you duplicate this, that means the counter will get increment twice. So then let's move on to the other one, which is useRef. So similar to the use state, you have to first import it. Once you import it, you have to mention that initial value which is being there. And for this, there is no setter or getter function which is being used, since it is a type of a reference. So once you have a count, in order to change or any update value, you should say count.current. So count.current, if you do a console log, it will give you a current count. And if you want to change it, you can say count.current +1, and then you save it in this count.current. Pretty much the same like we usually do for the variable. One thing here is the component won't re-render for useRef. That is one plus point for this. So if you want for any internal calculation, then useRef is a good method. Uh, Third hook which is there is useEffect. So first thing is used to that we use effect to import it. Once it is being imported, this is how a use effect is created, wherein a callback function is being passed and a dependency array. So if a dependency array is empty, that means when component is mounted, that time this console log will get executed. And if there is state in this component, and if that state is updating, then this thing won't get executed since the dependency array is empty. But if you had a state like a count, then you and you want like every time a count is being changed, you want to run some logic. So that count you can put it over here. So first is when the component is mounted, that time use effect will run, and when a count is changed, that time you will run this thing. Also, if you keep this empty like this means every single time this will run. That means on mount it will run, or if there are, let's say, 5 states and any of the 5 state is being changed, that time it will run. So we should avoid keeping this. It's better always to keep an empty dependency array. Also, there is one more thing in use effect, which is a cleanup function, or basically a function we can say when a component is unmounted. You must have seen. So it might be a situation wherein, let's say, you make an API call when a component is mounted, and that API call, let's say, takes around 1 or 2 minutes to process everything. By that time, you are moving on to other component. So that means the existing component which is there, which is this component, is being unmounted. And once that response is, once you get the API response, it tries to set some state in this. So what happens it is a memory leak which is being produced. So in order to avoid that, what you can do is you can write a cleanup function. So you can say simply return, you can do, and then you can write some logic. For example, you can write a logic wherein you are aborting that API call. So if this component is unmounted, abort any fetch call which is being made. So that so this is how you write and cleanup function. Whatever logic is there will be coming over here. Then the third hook which is there is sorry, the fourth one is use context. So so as I said, use context is used to share some data between the sibling nodes, especially between the sibling nodes, so that you don't do the prop drilling. Prop drilling is basically passing on from parent to is all the children till it reaches its destination. So in order to avoid that, we make use of use context. So for use context, we are using two things needs to be imported. One is use context, and second is create context. So first is thing is you need to create a context. So I've created a context call for counter, and then this is the state which is there, which I need to be shared between two components, wherein component one and component two, and these components are sibling node. Sibling means they are at the same level. And if I want to share that data between them, so first I need to create a context. Once context is created, you have to use this context and then say dot provider and value. And inside value, you should pass whatever things you want those component to access. In this case, we want the count as well as an ability to update the count. So I am passing the count and the setter function, which is set count. Now inside those respective component, you need to access that context. For accessing the context, you need to use context. and then you have to mention the context name which is you have created. And once you have done that thing, you will be able to extract the count and the setter function. This is an object restructuring which is being done. And this is the similar thing, like you are setting a state, a normal state, which I have shown in the previous example. Similarly, like this for the other component. So in this way, we are not passing as a props. Instead, we are taking help of context to access those state. Usually, the way things are created is there is a separate file for context, and we keep everything over there. And similarly, this thing, and here we pass a children. Children's in React is basically when you pass a component to another component. As a props, when you pass a component, that thing is called children. So you can create a separate file for that. But for basic understanding, this example is enough. So the fifth hook which is there is use callback. So use callback basically caches that function. So in this example, I have created one fetch function which is doing some, let's say, data fetching, and there is one state. So that state is count state. So every time when I click on set count, it is setting a new count, but at the same time it is re-rendering this entire component. So when this entire basically component, that means from here to here, everything is being recalled, this fetch function which is there is recreated. Now let's say here we had used a use effect hook, and inside use effect we are doing a data fetch. And if you are using ESLint, it will always ask you to add this whatever thing, any external function if you are using, you have to add it over here. So what will happen is I have changed the count. Yeah, it is so this function is being recreated. A new reference is created for this, which basically this use effect checks that it sees that previous reference for this function and current is differing, and that's why it thinks that we should execute this thing, and this function get executed unnecessarily. So in order to prevent that, we are making use of callback. So callback is something like this, wherein you say callback and you wrap that entire function which is there. So basically whatever logic is there, you put it in a callback and you add the logic inside that. Similar to use effect, there is a dependency array for this, which means you are saying that on at what time you want this function to be recreated. Otherwise, what will happen, it will form a closure on that, and it will always remember that whatever the value is being set, or the variables which are being used for that. So in our case, there is no external variables which are being used, so I don't need to specify anything. So when component is being mounted, that time this function is created and the reference is being stored. And whenever I click on set count, again that function is being recalled, but this time this function is not being created, it is staying as it is. And so use effect detects it, it sees that there is no difference in the reference and doesn't execute this function. So this is useful, especially when you are making use of any function in use effect and all. Then sixth hook is use memo. So use memo is memorizing the return value of a function. So here in this example, I've created one state. I've imported a use memo, use state. Two states I've created, and this is that expensive function which is there. So this function is being executed on every single time. So this is how I've written it over here. So every time a component is re-rendered, this function is being created. Now, if you see that this function needs is dependent on this count. So that means only when this count is changed, I want the output to be shown over here. If the count is 1, let's say 1, whatever it is, I don't want to show, I don't want to execute that function. There is one more state which I've created, which is a set name state. So if I am setting a state which is a name, I am not basically changing count. I am basically changing the name. So this value will remain the same. But since the components is re-rendering, this will get executed and this will get recalculated and it will return the value and you will see the output over here. Now, in order to prevent that, we are making use of use memo hook. So this is how you write that use memo hook. So this is, you have to first create a separate function for this and you have to say use memo and you have to pass whatever thing was there for here. This entire function needs to be present over here. So this will be there and this function is being passed. And again a similar thing like dependency array. So this our expensive function is dependent on count. That's why I've kept count as a dependency array. Only that time I want that function to be executed. In that way, basically it knows like the value is being changed and you have to calculate it. So now what will happen is once that is done, this is the syntax, the way you have to call it. So this is the cached expensive function and this is a use memo hook and this is the count. So if I am changing the name for the first time, it will get the value. Let's say it is let's say 1. It will show 1. Again, let's say I change the name. That time it won't execute this thing. It knows that value is same and also the count value is not, the output is same and the input is same. So it won't count it. So so that means this processing of this is being stopped. So this is the whole idea behind the use memo hook. And the last hook which is there is the useReducer. So useReducer, as I said earlier, it is for handling a complex state. Like if you have 2-3 states, one approach is either you create a state like how you created for useState. There is a setter, then there is one thing which handles, or you can make use of useReducer. So for useReducer, first use useReducer imported. Once it is imported, you write a useReducer. Here is the name of the function which will be handling that logic for the useReducer, and this is the initial state. So in our application, I have kept count and a username. Count is initially set to 0 and username is set to test. This state which is there, this state basically represent this state, and this entire object is same. And dispatch is basically a way wherein you can trigger this reducer. So this, if by using dispatch you are calling reducer. So if you see the reducer, it's simple. It's just a function wherein you are passing a state and an action. Inside that there is a switch case. The switch case is on the type of the action. So in our case it is counter and username. So counter will be increment or decrement and username is updating the username. So that you have to mention in this case, and then you have to put a return statement. Now one thing we should note that you are updating this entire object. So if I am updating the test, that means I need to copy the existing things which are there. So that's what I have done. So I have created a new object. Inside that I have unpacked all the things which were there existing in the state, which is the current state, and then I am overriding that count with the whatever changes I want. So if I want to increment count, so I will say count colon state dot count will give me the current count and plus 1. So 0 plus 1, it will set 1. So count will be 1 and it will override the existing thing. And you are returning a new object. So since we are returning a new object, that means a new reference is created, and that's how basically the component knows that we need to re-render, and entire thing gets re-rendered. Similarly for update, it is similar thing, but only one thing is that here everything was already being present. But for user, you are passing a user is basically wherein there is some input in the DOM which you are making. So that is a payload. So in order to pass a payload, we are using action.payload. So action.payload is basically the thing which you have passed. and you are setting it over here. Now how to call this reducer, we can see it over here. So first we will see for count. So I have kept an button wherein there is a on click event. This on click event basically calls an anonymous function and it uses dispatch. Now inside dispatch you have to create an object, and inside that you have to mention what it is, where what type of action it is, whether it is increment, decrement, and accordingly it will execute this thing. Now in case of update user, we need to pass something to that reducer. So in order to pass something to the reducer, first we are mentioning what is the action, and second is the payload. So in our case, it is the whatever the event on change event is capturing the input that we are passing as a payload. So event.target.payload, it's simple, it is from the event, and payload will have that value, and then it will be able to be accessed over here, action.payload. So these are all the 7 hooks which you basically need. um, mm, and yeah, that's all, nothing else.